Let's go over LeetCode question number 728, self-dividing numbers. Now the question says, a self-dividing number is a number that is divisible by every digit it contains. So this is the definition of self-dividing number. Now we are given an example. 128 is a self-dividing number because 128 mod 1 is 0, mod 2 is 0, and mod 8 is 0. Now let's look at that again. So we have number 128. And what are the digits for 128? It's 1, 2, and 8. And you have to check, is 128 mod 1 equal to 0? Well, it's true. So let's keep going. Is 128 mod 2 equal to 0? Well, this is true. 128 mod 2, is this equal to 0? Well, it's true. So if they're all true, we are going to add this number into our output array. Let's keep reading. Also, a self-dividing number is not allowed to contain the digit 0. So if a number has 0, it's not self-dividing. And next, given a lower and an upper number bound, output a list, so that's going to be an array, of every possible self-dividing number, including the bounds if possible. Now let's get our example. And we have left is equal to 1 and right is equal to 22. So that means that this is going to be our lower bound and this is going to be our upper bound. Now what we have to do is we want to start iterating starting at the lower bound, which is represented by left, until we reach our right, which is our upper bound. And it's telling us to including the bounds if possible. So we want to loop this until left is less than or equal to our right, and we want to start at left, and our left is 1 and our right is 22 for this question. So first thing we're going to do is we're going to start with the number 1. Well, is number 1 mod 1 equal to 0? Well, this is true, right? So what we do is in our output array we put 1 here, and the next number is going to be 2. Well, is 2 mod 2 equal to 0? Well, this is true. So we put 2 here. And obviously, all the numbers divided by itself is going to be true, right? So we're going to have all the numbers through 9. And that's what we have over here. So 1 through 9, we have all the numbers. Now, our number is going to be 10. Well, we have a 0 here. That means that it's not self-dividing. And that was part of our definition over here. So we skip that. And we check the number 11. 11 mod 1 is equal to 0. Well, this is true. And again, 11 mod 1 is equal to 0. Well, this is true. So we put that in our result. And we have 11 here. And we keep going on till we hit our number 22. And it has to be inclusive. That's why we are having number 22. And obviously 22 mod 2 is going to be 0, which is true. And it's same for the second digit because we have 2 of the same digits. So we put that in our result. So let's go over a digit that's not self-dividing. For example, number 17. So we have 17 and we have 2 digits. The first one is going to be 17 mod 1. Well, is this equal to 0? Well, it's true. And we have 17 mod 7. Well, is this equal to 0? No, it's not. So we are not going to push it into our array. And when we're done iterating the whole thing, we just return our output and we are done. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over our solution, and our solution is going to have 2 parameters, which is going to be left and right, where left is going to represent the lower bound and right represents the upper bound. And we are going to return an array of self-dividing numbers that's between our left and right bound. Our time complexity is going to be O of n squared, and space is going to be O of n. Now let's start coding our solution. So first thing I want to do is I want to create a variable named output, and this is where we are going to store all our results. And let's just return that over here. Okay, that looks good. And now we need to be able to go through all the numbers between our left and right bound. And remember that our number is going to start at the left bound, and we are going to go all the way until we hit our right bound. So let's just use a for loop for that. So for let num is equal to left, and as long as number is less than or equal to right, because it has to be inclusive, and we are going to increment num by 1 each time. And why did I name this num? Well, it's because any number between my left and right bound is the number that I'm going to look at to check if it's self-dividing or not. And here I'm going to make a variable named, let's call it string number, and this is going to store the string version of our current number. And we need this because we want to be able to iterate through our number, our string number, and look at each and individual digit and see if it's self-dividing or not. So here we are going to make another loop. Let I is equal to 0, I is going to be less than string num dot length, and we are going to increment by 1 each time. Now let's console log string num at index I, and you can see that we have a bunch of digits or numbers, right? So 1 through 9, it's going to have only single digits, so it's just gonna print that. And we have our 10 here, so 1 and 0, 1 1 for 11, 12, 13 and 14, and so on and so forth. So let's get rid of this. And now is the core part of our solution. And for this one, we are going to check if when our solution or our number is not self-dividing. Well, if you remember, a self-dividing number is a number that is not divisible by 0. So let's handle that first. So if my current number, so parse, so I want to convert my string number into a number. String num at index I is equal to 0. I just want to break out from my loop. So this is to check. Well, if my current number is equal to 0, I just want to stop my loop because I know that it's not a self-dividing number. And parse int converts this string number into an actual number. And next, I want to check, well, if my number is not divisible by the current digit, that means that I don't have to keep iterating to check if that number is self-dividing or not. And if you want, you can actually just make a variable here to make it more readable and name it digit and just set it equal to string num at index I. And we can just get rid of this over here. Or we can just make this parse int over here. Let's actually do that. We can get rid of parse int over here. Okay, that looks good. Now we need to check again, what is not a self-dividing number? Well, self-dividing number has to be divisible by whatever our current digit is. So if it is not divisible by any one of the digits, we know that that is not a self-dividing number. So we do if our number mod our current digit is not equal to 0, that means that it's not a self-dividing number, so we just stop, we break. Finally, we need our last case, and this is where we are going to push in our result. So if our current index is equal to string num dot length minus 1, we just want to push in our result. So output dot push our num. So what we do here is, well, if we are done iterating through all the digits, and if our current index is the last one, that means that we checked all the digits. So we push our result over here, and then as you can see, we have our result printed over here, which looks good. So let's go over our code one more time. Our outer loop is checking or iterating through the bounds of the numbers. So starting at the lower bound, and we iterate until all the way to the upper bound, and we convert our current number into a string so that we can iterate through and get the digit. And here we got the digit, but in order to make comparisons, we have to first make that string digit into a number. So we use parse int to do that, and we check, well, is a digit equal to 0? If it is, that means that we can just stop our loop because a self-dividing number is not divisible by 0. And we check again, well, is the number mod digit not equal to 0? So is the number not divisible by digit? If so, we just stop our loop and then we keep going. Well, is the index equal to the last index of the string num.length minus 1? Well, if it is, it means that we checked all our digits against these two conditions, and that means that these two conditions failed. So if it fails, it means that it is divisible by all of our digits. So we push it into our result, and finally we return our array with self-dividing numbers. Now let's go over our second solution. And for our second solution, we're going to use a different method to solve our problem, but obviously the overall logic is going to be the same. The first thing I'll do is I'll create a variable called output, and we'll have our result over there and return output here for now. Okay, that looks good. Now for this one, I'm going to use a bunch of methods to solve this problem. And what I'm going to do is I'm going to convert my left number into a array of strings. And if you remember from our previous solution, what we did was we iterated through all the elements in our array, starting at left and until we reach all the way to right. So because we were given lower and upper bound for our numbers. But for this one, for each left value, what I'm going to do is I'm going to iterate using while loop as long as left is less than or equal to right. And I'm going to make left represent the number itself. And again, before, when we had our for loop, we had our index representing number itself, but here we're going to make the left variable represent the number. So each time we run our while loop, our left is going to increase, and we are going to run a certain operation on this left variable, which again represents a number. So now I need my if statement. First, I need to convert my current number, which is represented by left, into a string. Pass in a string, and I'll pass in my number, and I want to make this into a array because I want to run some array methods. So in order to do that, I'll use split and give it an empty string. And on this array, I want to use a function named every and pass in an argument named digit and check, well, is my current number, which is represented by left, is this divisible by my current digit? If it is so, I want to push that number into my result variable, which is output. And now we can see we have our result, right? But let's go over our code. So we are iterating through our left and upper bound, starting at left bound and all the way to right bound until we reach that number. And we are letting left represent the number. And if you remember from our previous video, again, our number was represented by the index, which was called num. But here we are going to make left the number, and we are incrementing that by each time we run our while loop. Given that when our number is 1, we're going to convert our number 1 into a string, and then we're going to split it. So we're going to have an array, but for now we're just going to have one element, which is going to be a stringed version of number 1. And on that array, we are going to run this method called every, and what this does is it determines whether all the members of an array satisfy the specified test. Test is this: is our current number, which is represented by left, divisible by the digit, and we are getting that digit from this array, which only has one element for now, which is 1. And if all the elements are divisible by the digit, this is going to evaluate the true. So our if statement is going to evaluate the true and push in our element to our output. But if it happens to be the case that, let's say our number was 10, so our left is 10 now, we convert that into a string and we split it. So we're going to have an array with 2 elements, which is going to be 1 and 0, and we run every method on that array, and at first our digit is going to be 1. Is the number, correct number, 10 divisible by 1? Well, it is, right? So that's true. And we go on to our second element, which is 0. Well, is 10 divisible by 0? Well, no, it's not, right? So it fails. So if any of one condition fails for the digit, this is going to evaluate to false. And then we just exit out of this if statement because it fails. And then we hit this line, increment our left, and then we go on to number 11, and this keeps going until we hit our last number, which is 22, and finally return our result. If you guys find this helpful, make sure you guys like and subscribe. Thanks.